The threshold of the observable universe has remained a mystery for hundreds of years, generating interest and hypotheses among scientists and enthusiasts. The James Webb Space Telescope, JWST, is the key to uncovering this cosmic mystery with its powerful lenses that look deeper into space. It recently made a stunning statement about the edges of the observable universe. Understanding the limits of the universe requires understanding the observable universe, which includes everything we can see, measure, and study from Earth or in space with our telescopes and probes. Currently, this includes stars, galaxies, and other celestial bodies in our field of vision. The observable universe is only a small part of the whole universe that we can see and understand. Although the size and shape of the entire universe are unknown, the observed universe is estimated to be approximately 93 billion light-years in diameter. A light-year is the distance light travels in 1 year, about 5.88 trillion miles or 9.46 trillion kilometers. Thus, the diameter of the observable universe, 93 billion light-years, covers an unimaginably large area of about 5,468 billion miles, or 878.4040 billion kilometers. About 13.8 billion years ago, the universe was born in a mighty explosion. This explosive event caused a rapid expansion, and since then the universe has been expanding faster and faster, driven by mysterious forces such as dark energy. As the universe expanded, particles of matter began to join together under the influence of gravity, forming structures such as stars, galaxies, and eventually even planets such as Earth. Despite the vastness of the universe, it is mostly empty. If our entire solar system shrank to a quarter of the size, the nearest star would still be 2 football fields away. It is only in our Milky Way galaxy, one of billions in the observable universe. The concept of the limit of the universe is a confusing topic that has long fascinated scientists, philosophers, and thinkers. There are various theories about what lies beyond, but the truth remains elusive. However, 3 theories stand out. First, the universe goes on forever, with no end in sight. This principle is based on the cosmological principle that the universe is isotropic, meaning that it looks more or less the same in all directions. If this principle is true, it means that the universe extends to infinity without limits. Second, the universe is finite but has no clear edge. This means that it is like a massive ball, and if you keep moving in any direction, you will eventually be back where you started. Third, the multiverse principle suggests that our universe is just one of many, similar to a group of parallel universes, each with its own rules and properties. These universes can be completely separate from each other or connected in some way. The James Webb Space Telescope allows us to look far back in time and discover unexpected objects in the early days of space. Its advanced features have allowed astronomers to see back to the early days of the universe. In a recent study published in the journal Nature, the James Webb Space Telescope discovered 6 large galaxies that existed between 500 and 700 million years after the Big Bang. Scientists only expected to find small, newly formed galaxies, but the James Webb Space Telescope surprised them. These galaxies are much larger than anyone ever imagined, challenging what we thought we knew about the early cosmos. Nicknamed the universe breakers, these massive galaxies have scientists scratching their heads. They defy 99% of previous galaxy models. We thought that galaxies began as small clouds of stars and dust that gradually grew larger over time. These universe shatters proved us wrong. When the first recordings and high-resolution images from the telescope became available in July 2022, scientists were surprised. They were surprised to see these galaxies as massive point light sources and questioned the interpretation of the data. The surprising appearance of these massive objects, almost as if to see them, surprised everyone. By using spectroscopic techniques to study light at different wavelengths, scientists can reveal valuable information about these galaxies, including their composition, size, and distance from Earth. The question at the edge of the observable universe continues to capture our imaginations and drive scientific research. The James Webb Space Telescope is poised to reveal even more secrets of the cosmos, changing our understanding of the universe and our place in it. It exceeded all expectations and developed faster than expected. It is even possible that some of the items identified through internet registries are something completely different. While most of these are likely galaxies, it is possible that some may be hidden supermassive black holes. The known stellar mass of the universe is thought to be up to 100 times greater than previously thought, a stunning discovery even if only half the sample is considered. With the powerful James Webb Space Telescope, an international group of astronomers also made an extraordinary discovery. They discovered the oldest and most distant galaxies ever confirmed, taking us back to a time when the universe was a fraction of its current age, less than 400 million years after the Big Bang. Light from these galaxies reached us more than 13.4 billion years ago, as detected by the telescope. Like early observations from the Hubble Space Telescope, the first images from JWST revealed several possible galaxies. Using precise spectroscopic observations, astronomers confirmed 4 of these objects, allowing them to study the physical properties of the galaxies, as well as determine their distances precisely. To determine the distance of a galaxy, astronomers calculate its redshift. Estimates of redshift can be derived from images taken through various filters, but spectroscopy is better for precise measurements because it divides an object's light into wavelengths. The new findings focus on 4 galaxies with redshifts greater than 10, indicating that they are very distant. 2 of these galaxies were previously observed by the Hubble Space Telescope at redshifts of 10.38 and 11.58. However, the JWST images revealed even more distant galaxies at redshifts of 13.20 and 12.63, dating back to about 13.5 billion years ago, revealing an ancient cosmic history. In addition, JWST's Advanced Deep Extragalactic Survey, JADES, is an ambitious program that has taken up more than a month of the telescope's time. It aims to provide unprecedented insights into the early cosmos. In 2015, the Instrument Cluster Consortium proposed the project and formed an international partnership called JADES, which includes more than 80 astronomers and scientists from 10 different countries. Starting with the Near-Infrared Camera, NIRCam, the JADES program devoted more than 10 days to observing a small region of the sky, including the Hubble Ultra Deep Field. Probing at 9 different infrared wavelengths, the JADES team made a stunning discovery. Nearly 100,000 very distant galaxies, each billions of light-years away. Then, using the NIR-SPEC spectrograph, the researchers collected light from 250 faint galaxies during a 3-day observation period, allowing them to reveal the gas and stellar properties of these galaxies and obtain accurate redshift values. These measurements allow astronomers to determine the intrinsic luminosity of galaxies and estimate the number of
stars they contain, taking into account the deep study of galaxy formation over time. Even without direct knowledge of their early stages of growth, reading galaxies can be as difficult as understanding people. The early generations of stars profoundly affect the future of galaxies, just as our early experiences shape our lives. This is an incredible time in history because the transformative power of the James Webb Space Telescope is answering many questions about galaxies. NASA's Deep Space Observatory Telescope is revolutionizing our understanding of space and revealing a treasure trove of new discoveries. The James Webb Space Telescope, a pioneer in scientific research, gives us incredible views of galaxies, planets, stars, and other fascinating cosmic phenomena. Launched in December 2021, Webb, which is expected to operate for 2 decades, is just beginning its space journey. Exceeding the standards set by its predecessor, the Hubble Space Telescope, Webb captured the imagination of scientists and the public alike, inspiring a wave of scientific enthusiasm. People around the world are eager to enhance the telescope's raw data, share its stunning images, and gain new views. After a flawless deployment process, Webb stunned us with its first images in mid-July, giving us unprecedented insight into countless parts of our universe. Using an advanced infrared telescope, the James Webb Space Telescope allows us to study the most distant galaxies in extraordinary detail and peer deep into the past. Within days of coming online in late June 2022, JWST's powerful instruments began to reveal hundreds of previously unknown galaxies that are older and more distant than ever imagined. In addition, the telescope's capabilities allow scientists to collect vast amounts of light from celestial bodies, including exoplanets and newborn stars, revealing their composition and tracking their trajectories through space. This wealth of information is already revealing intricate details about the composition of the atmospheres of planets hundreds of light years away from Earth, suggesting their possible habitability. In addition, the James Webb Space Telescope may have identified the oldest black hole ever discovered by analyzing the faintest traces of light in the universe's infancy. This supermassive black hole, millions of times the mass of the Sun, is at the center of a young galaxy that was formed 570 million years after the beginning of the universe. Thanks to Webb's powerful cameras, which can look back in time to the earliest moments of the cosmos, this monumental discovery offers glimpses of the cosmic dawn. Although black holes proliferated a billion years after the Big Bang, the origin and distribution of these enigmatic cosmic creatures are still mysteries that baffle astronomers.